In this module, we'll add login functionality to our web app and learn the basics of MySQL. First, we'll do a simple Python-based login to understand the basics of processing forms, and then we'll switch to MySQL to create a much better method for logging in. With home.tpl opened, let's add a method attribute and an action attribute to the form tag. The method attribute defines how we will send all of our form data. A method can be either get or post. Be sure to download the PDF titled Get versus Post in this module for the differences between the two. For this form, we'll use post. The action attribute defines where we'll send our form data. We'll set up a route for our action by simply writing route, then specify any route, but with an additional attribute of method equals post. This means that the first /route is simply taking us to our home page, while the second /route with the post method will process our form. We'll add a def called login for this route, but we can give this def any name that we want. To get what the user types into the email input, we'll need the name. In this case, it's email. To get the input data, we'll create any variable name and assign request.forms.get to it, specifying the name of the field as the argument of get. We'll do the same thing with password. To check if our form is working, we'll simply return email for now. Now that we have a post route, let's write the name of the route into action on our form. Finally, to make our button post a form, we'll add a type of submit to the button tag. When we save and refresh our app, we'll see that our form works nicely, displaying the email that was typed into it. If we return the password too, we'll see the form returning that as well. Now let's use some simple Python logic to make a very silly type of login, but one that will help us understand how our code works. Under password, we'll add a selection statement that if email equals 123@mymail.com and password equals 123, then we'll return welcome. Else, we'll return invalid. When we save and refresh and type in the correct credentials, we see welcome. If we type something wrong, we see invalid. This means our form is working nicely, but of course, we would never want to allow our users to log in this way, adding a new selection statement manually for each user. Instead, we'll make this form dynamic using MySQL. In earlier modules, we defined MySQL as a database management system. By using specific MySQL commands, we can create, modify, and delete data from our database. To start a MySQL database, we'll go to Databases and create one using a password. Be sure to never forget this password. The database should take a few minutes to initialize. Once our database is initialized, we'll see the host address, username, and console for the DB. Click on the new console. Our first MySQL command is to see what tables our database has. We'll write show tables and end the line with a semicolon. Our database is empty, so let's create a new table called users. This will hold all of the user data such as their email and password. We'll write create table and the name of the table, users in this case. In parentheses, we'll specify the first field name, its data type, and make this ID auto-increment for each new entry into our table. We'll also set this field to be our primary key. A primary key is the field that makes each row or record unique. Each new entry into our table is a row or record. Now, using a comma, we'll create our next field, user email, set it as a variable character field or varchar data type that can hold between 0 and 50 characters. Varchar is basically a text data type with a size limit. Next, we'll add a condition of unique for this field to make sure that each new email entered into our table is unique. We don't want repeating emails in our database. Now we'll write comma and add another field for user password. Of course, passwords can be the same for different users, so we don't need the unique constraint. Finally, we'll add a field for whether a user is an administrator or not by using the Boolean data type. A Boolean data type is a data type with two possible values. In this case, we'll use true or false to indicate whether the user is an admin or not. These will appear as 1 for true and 0 for false in our table. Now we'll close the parentheses and use a semicolon to commit to the creation of the table. If we press up to get the previous show tables command, we'll see that we now have a table. To get more information on a specific table, we can use describe and then the name of the table. Our next SQL command is to insert data into our tables. We'll add data manually into the table for now to get our first login to work, but we'll code the app to do this automatically for signups in the coming modules. To insert data, we'll write insert into the table name, values, and then specify the values in parentheses separated by commas. For the user ID that auto increments, we'll simply write null. This will turn into a number in our table. For the user email, we'll write an email in quotation marks. For the password, we'll write a password in quotation marks. And for privilege, we'll write true. We'll end this command with a semicolon and hit enter. Now, if we select everything from the users table, we'll see our newly added data. Notice how the user ID is now set to 1 and the user privilege has turned to a 1 for true. We can add more data by simply pressing up to get our previous command and changing the information. Now our table has 2 users. We're ready to log in using these credentials. In Bottle, we'll import MySQL to be able to use MySQL commands with Python. Now in our post route, we'll get rid of our selection statement and make a connection to our database. We'll give our connection a unique name. In this case, we'll use db and then write equals MySQLdb.connect. In the parentheses, we'll write the host address, user, password, and console name. All of this information, except for password, is under databases in our account. Now we'll create a cursor that allows us to move through our database. We'll call this cursor C. Now, using the cursor, we'll execute some SQL code by writing the cursor name, execute, and writing our SQL inside of the execute method. Here, we'll want to select everything from users where user email is equal to a value. This value is the email passed through the form. Notice how we use a string format to do this, replacing the %s with the email in the neighboring parentheses. The reason for doing this is beyond the scope of this unit, but it's good to know that this could prevent a type of attack called an SQL injection. Next, we'll commit to this, making all changes permanent. We want to save the record or row that the query returns. To do this, we'll write a variable, row in this case, and apply the fetchOne method to our cursor. This retrieves the single row result of the query as a tuple. Each index in the tuple would be the selected fields in the record. If an email was found, our tuple will look something like this. If the row is empty or none, we'll return no such user. Otherwise, we'll check if the second index of that row matches password. If there's a match, this means that the email was valid and the passwords match, so we'll return welcome. Otherwise, it means the password is incorrect. Now, if we save and refresh, we'll see that we can log in using the data in our database. If we type an incorrect password, our app notifies us.